Okay, guys, your homework should have been checked already. If not, just pause the video until it gets checked, and then we can just start checking our answers here. Kind of annoyingly, these are the book answers here. They didn't really label like sine, cosine, tangent. So let me see if I can go through and do that really quick for you. So like on number 18, remember 18, 19, and 20 are really the same. It's just SOHCAHTOA here. The book gave decimal answers. I'm totally okay with just fraction answers. But that is the decimals that you would get here. 18, 19, and 20, do not use the trig buttons on your calculator because we don't know the angle value, right? So you can only do that if you have the angle for sine, cosine, and tangent. So on this one, if you did sine, right? So I think this is going to be angle L. So this is going to be sine of L would equal 3 over 5. So then this would be cosine of L would be 4 over 5. And then tangent of L would be 3 over 4. So then that makes this is sine of J would be 4/5. So cosine of J would equal 3/5. And then tangent of J would equal 4/3. So I'm kind of annoyed that the book wrote it like this. I think they just did sine, cosine, tangent in the same order there. So these would be sine, cosine, and tangent in that order of angle J, right? Because the opposite side of J is 84. So this would be sine of J, cosine of J, tangent of J, and so then switch it around. This would be sine of L. Is that not right? Why does this annoy me so much? Okay, sorry. I wish this book was not such a pain. Okay, sorry, I should just wrote these out myself. 84 over 85 would definitely be sine of J. But 13 over 85 would definitely be sine of L. But 84 over 13, that's TOA, right? So that would be tangent of J. 13 over 85 could be cosine of J, since we already have sine of L. Right, they repeat themselves. So then 84, 85 would also be cosine of J. Cosine of L. Good gravy. We could just stop listening to me at this point. This is what happens when I'm making notes at almost 10 o'clock at night. I just feel like that they should have switched those around, but alright. This would be tangent of L. Hopefully yours is better than mine. I did want to give you number 20 with the square roots here, just to show you that they're simplifying them. Like on number 20, you might say, where did they get the square root of 5s? Well, if you have the square root of 15 divided by the square root of 3, you can divide those out as a square root of 5. So I'm not going to do all of these because obviously I'm a mess. But if I did, I'm just going to kind of ignore this and do my own. If I did the sine of L, sine would be opposite of L, which would be 2 square root of 3, over the hypotenuse, which would be 2 square root of 15. Well, definitely the square root of, or the 2's cancel out. And maybe you left it as square root of 3 over square root of 15, but since they're both in a square root, you can divide that out and make that 1 over the square root of 5. And you might say, well, that's not on here. But remember, we like the square root of 5 on the top. So if you multiply the top and the bottom by the square root of 5 over the square root of 5, then you get this answer. And so that's where those work out really nicely to simplify. If you did the cosine of L, cosine would be adjacent, which would be 4 square root of 3 over hypotenuse, which would be 2 square root of 15. And now 4 divided by 2 gives me 2. And square root of 3 divided by square root of 15 gives me that square root of 5 on the bottom. And again, they're just multiplying on the top and the bottom, so that's where you get this answer. And then tangent of L would be 2 square root of 3 over adjacent, which is 4 square root of 3. And I don't know why they didn't cancel those out, right? Which is just 2 over 4. which is the same as 1/2, which they gave the decimal there, but they didn't simplify the square roots on that, which is kind of weird. And again, the cosine and the sine just switch, so you got the same answers, it's just labeling which one is correct. And so, SOHCAHTOA, 18, 19, and 20. Moving down to 25 through 26, when it says use a special right triangle, that's like that example we did yesterday. Well, I don't expect that you type that in your calculator. I expect that you can draw me the picture and solve it. So like I'm going to do 26. Says the tangent of 45 degrees. Well, remember, in a 45, 45, 90, right? These two are the same. So this would be leg, leg. And remember, this is leg square root of 2. So if I did the tangent of 45 degrees, that would be the opposite side of either one of these, because they're both 45. The opposite side is L, over the adjacent side is L, and no matter what that leg is, L over L is always 1, so that's why you get an answer, that the tangent of every 45-degree angle is always equal to 1. So those first 6 problems there were kind of just getting the basic SOHCAHTOA stuff. Then starting with number 30, really, really important stuff in terms of solving a triangle. And so we kind of went through a couple examples yesterday, and the big idea is figuring out which trig function to use. Is it sine, is it cosine, or is it tangent? It's not supposed to just be a guess here. Remember, you're supposed to look at what you have, look at what you want with the angle they give you. So, like on number 30, if I use 34 degrees as my angle, the side I want, right, it's not the opposite, because over here's the opposite, so the side that's x, that's the adjacent side, and then the other side I know is the hypotenuse, so you can't use sine, because we don't know the opposite side. You can't use tangent, because we don't know the opposite side, so that's how you know that you're using cosine, and you do the cosine of the angle, and I'm going to kind of write the formula out if this helps you. The cosine of angle z equals the adjacent side over the hypotenuse. And then this is where you need a calculator. The cosine of 34 degrees equals the adjacent side, which is x, over the hypotenuse, which is 28. So definitely you need a calculator. You need to make sure you don't take my calculators out of here, because I need to keep them all in here so we can actually use them during class. But not a bad idea to invest in one of these calculators, because it is helpful. But remember, you can go online. There's free calculators online. If you have a smartphone, there's a calculator on it. If you don't know how to use it, when I come back, I can show you. But just like I said yesterday, if you don't have a calculator, you could set this up, and then when you get in here, you could actually work them out. Because all I would do to solve this is multiply both sides by 28, and then that's where I'm going to type that in my calculator, and I should get the 23.2 that they got there as the answer. Okay, so 34 and 35, just same idea, but just some story problems. 34 is kind of just like the one we did with the treadmill, only it's about a springboard. You're trying to find how long is the springboard, so they tell us this is 6 inches, and this angle is 14.5. So here's my triangle, here's my right angle, and I'm looking for this side. So I don't know the hypotenuse, which means if I don't know the hypotenuse, I have to be using tangent there, right? And just to kind of do this one for you really quickly, the tangent of 14.5 degrees would be opposite, which is 6, over adjacent, which is x. You got to think a little bit more when the x is on the bottom to solve this. And so we can't solve that when x is on the bottom. So the first thing that I would do is get that x out of the bottom, and just like to move a number out of the bottom, we can multiply it over. So we can multiply x over, right? And that cancels that out. And now look at this side. I want to get x by itself. So how do I undo multiplying by tangent of 14.5? Well, I can divide by tangent of 14.5. And so what I'm going to get over here is 6 divided by tangent of 14.5 degrees. And we'll do some more like that today. Number 35, they draw the triangle there for you, and you're looking for the height of the roller coaster, right? So you're looking for this height, and I'm going to leave that one for you to do. And then real quick on 52, find the perimeter and the area of the triangle. Well, the first thing you have to do is find the missing sides, which means you have to do trig at least once. And then you could do Pythagorean theorem if you want. But I think it's just as easy to do trig twice. But you can't get those answers there on 52 unless you solve for the missing sides first. So if I solve for this side and I called it x, and I'm going to call this side y. Actually, do I even need to know what y is? Oh yeah, I do for the perimeter. I was thinking just for area. I don't. Never mind. Again, using 18 degrees, the opposite side is x, and the other side I know is the adjacent side. So I can say tangent of 18 degrees equals x over 12. And I need to get a calculator. So let's see here. Tangent of 18 degrees, and I'm going to multiply by 12, and I'm going to go just one decimal here, 3.9 I got. So I got x equals 3.9 centimeters. And then to find y, I could just do Pythagorean theorem, right? I could take 12 squared plus 3.9 squared, but I think it would be just as easy to use sine or cosine here because y is the hypotenuse. It doesn't matter whether you do sine or cosine because we know the other two sides of the triangle now. We know the opposite and we know the adjacent. I'm going to stick with the adjacent side since they gave me that one to begin with. So I'm going to do the cosine of 18 degrees equals adjacent over hypotenuse, which means it's just like that one we did up there where I'm going to multiply y over first, and then I'm going to divide cosine of 18 back over. Oh, not just 18. Cosine of 18. So on my calculator, I'm taking 12 divided by cosine of 18 degrees. And I get 12.6, about. So the perimeter of that would just be adding all those together, right? Perimeter would be the 12 centimeters they gave me, plus the 3.9, plus the 12.6. And hopefully that's close to the answer that they gave. 28.5. Oh, they went to 2 decimals. And then remember, area of a triangle is 1/2 base times height. So 1/2 times 12 times the height, which is 3.9, which would really just be 6 times 3.9, which is 23.4 square centimeters. And so they can kind of tie in perimeter and area, but you have to do trig there. Okay? So SOHCAHTOA, we're going to finish up notes today. We're not going to have a homework quiz on this until Friday, because tomorrow we're going to kind of spend one more day kind of reviewing these ideas and then have a homework quiz on Friday over this. So I have notes for you today. If you don't have them already, you can pause the video real quick until everyone gets them, and I'm going to go ahead and turn the slide here. Okay, so everyone should have notes by now. If not, just pause the video. And the one thing we didn't get to yesterday with SOHCAHTOA is yesterday we always knew the angle, or we were just writing the ratio of the angle. And we want to be able to solve for missing angles too, just like when we solve for missing sides. So yesterday we talked about SOHCAHTOA, where we can write sine, cosine, and tangent. But what if I wanted to solve for the angle? So like, what if I knew the sine of angle A equals 3 over 4, and if I wanted to solve for angle A, I need to get rid of sine. And you might say, well, let's just divide by sine. But you can't just divide by sine because it's not sine times A, it's sine of A. So you have to think about what we're doing when we get rid of stuff. We divide to get rid of multiplication because that's the inverse. We multiply to get rid of division because it's the inverse. We take the square root of x squared because those are inverses. And so today we're going to talk about the inverse of sine, cosine, and tangent. And it's just what gets rid of the sine when you want to get rid of it. And so the words here say if angle A is an acute angle and the sine of A is x, then the inverse, so let me do this here. The inverse sine is the measure of angle A. And so they used x instead of 3/4 here. But if sine of A equals X, which is right here, and I want to solve for A, I'm going to do the inverse. And this is kind of the symbol here. So the symbol for inverse sine, it kind of looks like sine -1. Maybe you saw that on your calculator yesterday and wonder what it means. We don't say sine -1, like we read that as inverse sine. It's just the symbol is a -1. It means the inverse. And when you do the inverse of sine times the sine of angle A, just like a square root cancels out the square, inverse sine of sine cancels it out, so you get A back. So, but you have to do it to the other side too, just like you have to divide both sides or multiply both sides. So we can say that the inverse of sine of X will equal the measure of angle A, and we'll practice this in a minute. And basically, sine, cosine, and tangent all have inverses, and that's how you solve for an angle. And so, I'm not going to spend as much time on each one of these. But if you have an angle, then you can find its inverse, right? So if cosine of A equals X, then inverse cosine of X equals A. And we can do the exact same thing with tangent. The inverse of tangent, if you know tangent of A equals X, then the inverse of X equals the angle measure, which means you can solve for missing angles today, which is kind of cool. Okay? So let's try some. So make sure you're paying attention, all right? You're really going to want to look at your notes today. Also, use your textbook. There's a lot of good examples in there to look at some of these to kind of see how to do it. Take good notes, though, because the homework's just like these examples today. So this says example 4 because it's kind of continued from yesterday's notes. But it says, use a calculator to find the measure of angle P to the nearest tenth. So we're looking for angle P, kind of just like yesterday. How do I know whether to use sine, cosine, or tangent? It's based on what I know, right? Why find QR when I have the other two sides? So you have to figure out, do we want to set up the equation with sine, cosine, or tangent? Well, I know 19 is the hypotenuse, so I definitely don't want tangent. How does 13 relate to angle P? It's not the opposite, right? Because the opposite would be over here. So it's the adjacent. So just like yesterday's homework, we could set up that the cosine of P equals adjacent, which is 13, over hypotenuse, which is 19. But unlike yesterday's homework, we're trying to get P by itself, right? So we can't just divide by cosine, but what I can do is I can take the inverse cosine of each side, and you don't have to show me that step each time, but I just want to show you that when you do that, that cancels out, and I get P, and then over here, I'm going to do inverse cosine of 13 over 19. So if you don't have a calculator, you need to get one. Let's not throw calculators. I know I tend to toss them at you sometimes, but I'm not here, so let's not throw calculators. But if you don't have a calculator already, you need to get one. And you should see that the inverse cosine button is right, like it's the same as the cosine button, but you have to hit second first. Second first, that's funny, right? So on your calculator, you're going to hit the second button, which is up at the very top corner. And then you're going to hit the cosine button, because it's going to do the one above it. And then you're going to just type in 13 divided by 19, or if you really want to do fraction bar, you can. But it should look like this on your calculator. Like it should have inverse cosine of 13 over 19. If it doesn't have that little -1 there, then you didn't hit second. If you're not getting it and someone around you is, please ask them to help you. So I'm going to hit second cosine. And then I'm just going to type, I just use the division button, but it doesn't matter if you use the fraction button. And you should get a degree. So I get that angle P equals 46.8 degrees. And you should put your degree symbol on there. So So this is 46.8 degrees, which is what they asked me to find. Right? So now not only have we learned sine, cosine, and tangent, but right above each of those on the calculator, you can see inverse sine, inverse cosine, and inverse tangent. So go ahead and try this one, and again, check with someone around you and see if they agree or disagree with you before I do it. One thing to make sure is which angle they ask you to find. Angle D, right? So again, really good thing to do is label the sides they give you, right? 16 is what compared to angle D? It's the opposite. And 23 is a hypotenuse. So that's the first thing you have to know is whether you're using sine, cosine, or tangent. And on this one, we use what they give us. We would use the sine, and you need to make sure you write this stuff out so you kind of know what you're doing. Like you should write the sine of D equals the ratio, which is 16 over 23. That's what you did on your homework yesterday. Today we're solving for angle D. So today we're going to say D equals, and to get rid of sine, I'm going to do the inverse on both sides. So I'm going to do inverse sine of 16 over 23. And then you should be able to do that on your calculator. Remember that you have to be in degree mode, so if you're not getting this answer and you see that you have an R or RAD at the bottom of your thing, your calculator, then you're in the wrong mode. 44.07 means that it should be A is the right answer. Okay? So now we can solve for missing angles, which is kind of a cool thing. So the last thing I have to show you today is now we can do something called solving a triangle. And solving a triangle means find everything that's missing. Every angle or every side that they don't give you, you have to find it. Which means unlike the last two examples where we just found one thing, you're going to have to find more than one thing on this. You have options here. You don't have to always do it the same way that I do it or that your neighbor does it, as long as you're doing correct things. Like Pythagorean theorem is still a correct thing to do, but sometimes you're going to have to do trig to do some of these. So I'll tell you that when it says solve a right triangle, you should always be finding three things. How many total parts are there in a triangle? 6, right? There's 3 sides and there's 3 angles. Well, in these problems, they're always going to give you 3 things. So they're going to either give you 2 sides and 1 angle, or they're going to give you 1 side and 2 angles. And depending on what they give you, changes how you have to set up that problem. Alright, so on this one, they give me 2 sides and that right angle, which means I have to find everything else that's missing. So I'm missing a side, right? So I'm going to have to find side AB at some point. And then I'm also missing 2 angles, so I'm also going to have to find what the measure of angle A is and what the measure of angle B is. So make sure you find all the missing things in these problems. Can we find the third side of this pretty easily? We can just do Pythagorean theorem, right? Like we've done that for a long time. So I'm going to do that kind of over here, if I can reach my microphone that far. I'm just going to say that AB squared, because that's the hypotenuse, or you could call it X if you want, equals the other 2 sides squared, which is 7 squared plus 4 squared. So that would be 49 plus 16 equals AB squared. And that would be what? 65? But that's what AB squared equals, right? So I'm going to take the square root of both sides, which means that I get the square root of 65. And if you can simplify it, just like before, I want you to do that. I do not want decimals, though. Okay? No decimals. So that part wasn't really new. We've done that. But to find one of those acute angles, I can't do that unless I know trig. Unless I know what I just showed you about inverse trig. You get to choose. You get to choose whether you solve for angle A first or angle B first, and both are okay to do. But you just have to pick the right trig function to set up. And you could really do any trig function because we know all three sides, right? So you like sine, do sine. You like tangent, do tangent. It doesn't matter as long as you set the ratio up. So that's what I mean by there's lots of ways to do the problem as long as you set up the right thing. So I'm going to find A first because A comes before B. And you could set up sine, cosine, or tangent. And I promise if you set it up the right way, we're all going to get the same angle. So I'm going to do tangent. How about that? Surprised you thought I was going to do sine, didn't you? I'm going to do tangent because tangent is opposite over adjacent. So I'm going to say that the tangent of A equals 4 over 7. So I'm going to type in my calculator that A equals inverse tangent of 4 over 7. And we're back to doing geometry, but that doesn't mean we're back to not showing work. So show me some stuff, all right? Don't just write your answers on these kids. So I'm going to do inverse tangent of 4 divided by 7 on my calculator. If I round to one decimal, I get 29.7 degrees. I promise if you did, it's a lovely 9. If you did angle, if you did cosine here or sine and you typed it in correctly, you should still get the same angle as me. Like, sine would be inverse sine of 4 divided by the square root of 65, and you'll get the same thing. What about for angle B? Do I need to do trig again to do angle B? I could. I could set up sine or cosine of tangent of angle B and do the same thing. But does anybody see a quicker way that we could solve for angle B? I know you know. Because in a triangle, you can know the angles, right? What do the angles in a triangle add up to? 180 degrees. So for that third one, you can just subtract to get that other angle, which means I think you should get 60.3 degrees. Sorry, I'm just checking my work here. Maybe you said you could just subtract from 90 because you know the two acute angles add up to 90. That would work too. But you can always, if you know two angles, subtract from 180 to get the third angle. So although there's 3 things you're solving for, you don't have to do a ton of work to get that. And you really only had to use trig one time in this problem. One more. I think just one more. Oh yes, thank goodness, right? I just wanted to do the other type of solving the triangle. So we did 5A, which is where they gave you 2 sides and 1 angle. So this is the other type they could give you, where they give you 2 angles and 1 side. And maybe we should label this here. Since I didn't label it, let's label this A, B, and C. And let's call this little a, little b, and they gave me the hypotenuse there. So again, remember you're missing 3 things. So I like to label what I'm missing, right? So I'm missing side A, or you could call that length CB. I don't care, either one. I'm just going to call it side A. I'm going to call this little b over here. And I'm also missing angle B, right? Which one's going to be the easiest to solve for? The angle, right? Because just like the last one, if I know 2 angles, what can I do to find the third angle? I can just subtract from 180, right? 62 plus 90, subtract from 180, and we get 28 degrees. Check if that works. Alright, so you can at least get one thing there. But to solve for side A or side B, again, you're going to have to do trig at least once. And again, I think the tricky part sometimes is you have options. You get to decide, do I want to solve for A first or do I want to solve for B first? It doesn't matter. You get to decide which trig function to set up at some point. Right now, the only side we know is the hypotenuse, which means you can't do tangent right now because we don't know the opposite or the adjacent side. But you even have a choice of you get to pick which angle to use. I would use 62 degrees because that's what the problem gave me. But if you use 28 degrees, you're going to get the same length for the side. So there's choices here, and sometimes choices feel like things are more complicated because you like there to be only one way to do stuff. But that's kind of what's cool about trig. So I'm going to do it one way, and if you do it a different way, again, you should get the same answer. If you don't and you're not sure why, ask someone. Jarrett is in here, and he does trig. He's been through Geometry 1, and also he's in pre-cal, and we've done a ton with trig. So if you're not sure why it's not working, feel free to ask him, or ask another math teacher. I know that they know how to do trig also, so ask them, and they can help you as well, since I'm not here today. So I'm going to use 62 degrees, and again, A comes before B, so I'm going to solve for A first. So if I use 62 degrees, then compared to 62 degrees, A would be the opposite side, yes? And I know the hypotenuse, which means I'm going to do the sine of 62 degrees equals A over 10. And that should be what we did on our homework last night. So then to solve that for A, I'm just going to multiply both sides by 10, right? Do my algebra. And I'm just going to take 10 times the sine of 62. Again, you need a calculator. And if I go to one decimal place, I get 8.8, which should be less than the hypotenuse, and it is. And now you have even more options, because if you know two sides of a right triangle, how can you always find the third side? You could do Pythagorean theorem. You could do another trig function. You could now do tangent if you want, because you really know one of the opposite or the adjacent side. You still could use 62 or 28. It doesn't matter. To tell you the how I do it, I don't usually do Pythagorean theorem because to me it's more work than trig. So I love SOHCAHTOA. It's easy for me. I'm just plugging into my calculator. And so I would do trig again, and I would actually stick with 62 degrees. So I would now look at B, and compared to 62 degrees, B would be the adjacent side. So I'm going to do the cosine of 62 degrees, and that would equal B over 10. And to me, that's way less work than Pythagorean theorem. Maybe you would do the sine of 28 degrees, and just to show you, I'm going to do both of these. You don't have to write them both down. Think about the sine of 28 degrees would also be B over 10. And when you type that in your calculator, you're going to get the exact same answer. And so that's what I mean by it doesn't matter as long as you're setting it up correctly. You're going to get the same answer. Which should be like 4.7. Which should be the same answer, even if you did the Pythagorean theorem. Why do I say that so weird? Pythagorean theorem. Sorry. Solve the triangle. Find all three sides. Three things. Okay. You should have some time left to work on your homework. Not a ton of time, but based on my calculations here, you should have at least 10 minutes here to start on this. So please start on it. Talk to each other if you need help. Talk to Jarrett if you need help. And I did every other 36 through 45 multiples of 3. 36, 39, 42, 45. That's just 4, right? And then 50, 51, 57, and 58. So that's 8 problems. Again, you need a calculator to do some of these. So maybe you can dig one out at home. If you have a study hall and you need to come borrow one from me just during study hall and then bringing it back at the end of study hall, you can sign it out by writing your name up on the board, and then erase it when you come back. But I really need you not to take these home because I need to keep track of them. They cost like 10 to 12 bucks, and you know that's not much to spend once if you'd like to invest in one, but it's a lot for me to spend on 20 if they go missing. So. Remind me when I come back to show you how to do it on the smartphone, because the calculator's like on the smartphone you have a scientific calculator on almost every smartphone, or you can Google it. Like there's free calculators online. You just have to do it opposite. So like you would hit the number and then you hit the sign button, because it's backwards from the calculators that we're used to for the most part. So I can show you that when I get back if you'd like me to do that. Okay, so get to work, and tomorrow we'll go through this and do a worksheet tomorrow. Okay?